Okay. Okay. So my name is Luca. I work at CRI in Berlin. I'm actually the leader of the containers team. And today we're going to talk about something which is the topic in here, containers. And especially like you have a cluster, a Kubernetes cluster, and you have your containers. And what do you want to do with that? Running it. Fine. We're going to touch into the details, the internal stuff. So how Kubernetes is actually running your containers. So first things, a step back. In Kubernetes, you're not actually running raw containers. You're running pods. Pods are the basic unit of execution, and they tie together multiple containers in a single service. Then Kubernetes takes care of basically scheduling them and doing some other task around, like how to recover from failure and how to scale your containers, your pods in your cluster. Cool. How does this work? There are basically three main entities here. First, you have a cluster, of course, and there is a scheduler in this cluster, which is the source of truth, which is taking care of scheduling your pods around. Then you have workers, and on each of these workers, there is one entity called the kubelet, which is a long-running daemon, a service, which is there, and it takes care of receiving order from the scheduler. And then there is another entity, which is the container runtime, which is kind of an abstract concept, which is the one that is really running things. So whenever you say, Kubernetes, I want to run this pod, Kubernetes goes, the scheduler takes some decision, and then delegates to the kubelet. The kubelet is running on some specific node, and then the kubelet goes and say, look, container runtime, which is typically Docker, I want to run this container altogether. And then Docker goes, and it runs actually your containers. So it's pretty easy. To visualize it a bit better, it works in this way. There is always some distributed key value store, which typically it's etcd, and that's where the logic, where the scheduling part is happening. Then there are components which take care of forwarding and propagating this information to other components. In this case, there are the scheduler and the API service. And then you have multiple workers with this kubelet, which receive this kind of order and just execute the container and the pod. We didn't start the timer, but it's OK. Seeing it as a hierarchy, actually you have the kubelet on whatever node, let's say on node 1, and then you actually have this container runtime running, for example, Docker, and then your pod gets executed with all the resources inside of it. So in this case, let's say that you have your service in there, which contains two applications, application 1, which is the main application, and some sidecar. Fine. I think it's pretty clear up to here. From here on, we go more into the technical part. In reality, when you're running your Kubernetes node, you have all these entities which are in there. Typically, you run it with Docker, which means that you have a kubelet, which is receiving some order, and then forwarding this order to the Docker daemon, the Docker engine, which then in turn has some internal components, for example, containerd, which take care of some other part of the execution, and then internally delegates to something else, for example, to runC, in order to run containers. And then there is some magic going around it in order to group this container together. This is, let's say, historically Kubernetes. Then at CoreOS, we had some kind of troubles, let's say, and we also had some kind of opinions. Those opinions were, there are too many components in here. Some of them, until recently, were not supporting auto updates, checkpointing, and restoring. And most of those are like long-running services, and they are tied to the lifetime of your container, of your pods. So we come up with an alternative, which is like, OK, let's write a different container runtime. So we keep everything, the scheduler and the kubelet as it is, and we just swap the bottom layer of it. And that's where we had Rocket. We implemented Rocket, and then we integrated it with Kubernetes. How we did it is basically with a single runtime, a single process, instead of a long-running daemon. And we also found out another interesting point, which is, what do you have already on your system? Systemd. Maybe you don't like it, maybe you like it. It's there, it has an interesting feature, so let's use it instead of re-implementing n daemons. So this is the usual configuration of a Kubernetes cluster running with Rocket. And then at that point, we had some problem like, OK, but there are some tools that really want to talk to some kind of daemon, and we don't have anymore a daemon to provide this information. So we also have some kind of lateral components which just provide this kind of read-only information if you want to query into that. which is fine. And then at that point, we had like, okay, already 2 implementation. The code is getting a bit dirty and messy to follow because there are different logic and different code paths. Fine. Let's sit down and have a discussion. And this discussion resulted in CRI, which is the new container runtime interface, which is being developed right now in Kubernetes. The idea is the kubelet really wants some kind of fine-grained control on what is going to be executed on every single node. And we want to move away, more or less, to the previous paradigm where there was just this big sync pod logic routine into something which is more granular, like kubelet, tell me which image you want to fetch from where, and which container you want to schedule to run in which pod, which resources you want in it, and that's it. And then we already have like some kind of protocol, a standard specification in order to let this component talks together, which is gRPC, which is an RPC mechanism based on protobuf. And this is how CRI came to life. It is currently experimental, so don't run it in production right now. It is targeted for some kind of alpha beta feature in 1.6, and it will definitely happen probably this year. Definitely, probably. Again, trying to visualize it a bit better. The idea now is we don't have anymore all those services talking together. We don't have different code paths. There is a single way of talking from the kubelet to the runtime service. And actually, there are another part, which is splitting up the image fetching from the container running part. All of this is going through gRPC. You just have to implement endpoints and being able to speak this gRPC protocol. And then something, in this case, the runtime service will take care of scheduling your pods. This comes with some other benefits, which is if you really don't like Docker or if you really don't like Rocket, that's fine. Just build your own, implement your own. There are already several implementations for that, and they cover different specific topics, let's say. So for example, with Rocket, that was our design, that was our approach. But then you have like Hyper, which is taking care of, I want to really schedule pods which are virtual machine. And that's it. How do you find more about what I just told you? Well, you go online and you join the Kubernetes community that we are part of, or you grab me outside. So just go on GitHub, check the Kubernetes code. This is done as part of SIG-Node, which is the special interest group inside the Kubernetes community taking care of all these low-level details. We have mailing lists, we have Slack channel, we have video calls, and that's it. And CoreOS is also hiring in Berlin, New York, San Francisco. So grab us.